There is a formation in northeastern Wyoming that has confused scientists for over a century. It rises 1,267 feet above the surrounding plains. Its surface is divided into hundreds of perfectly symmetrical columns, each one running vertically from base to summit. From a distance, it looks unmistakably like something that was once alive. It looks like a tree stump. A tree stump the size of a skyscraper. The official explanation is that Devil's Tower is a volcanic intrusion, magma that pushed up through sedimentary rock and cooled into this shape millions of years ago. And mainstream geology is quite confident about this. The rock is phonolite porphyry. The columns are the result of cooling magma contracting along predictable fracture lines. It is, according to the National Park Service, the largest example of columnar jointing in the world. And yet, the visual similarity to a tree stump is so precise, so geometrically perfect, that it has captured the imagination of millions of people who look at it and ask a question that science hasn't fully put to rest. What if the world we're living in is not the first one? What if before the forests we know, before the tallest redwoods and the ancient sequoias, there was something else? Something so vast that our entire understanding of what a tree can be would need to be completely rebuilt. My name is Paul. This is Mr. Origins. Today we go somewhere that no school, no textbook, and no mainstream documentary has been willing to take you. We go to the world before. Let's start with what we actually know, because the story of ancient trees is, even without any theory or speculation, one of the most extraordinary stories in natural history. The oldest living tree on Earth is named Methuselah. It's a Great Basin bristlecone pine located in the White Mountains of California. Its age has been measured by dendrochronologists, scientists who date trees by counting their rings, at approximately 4,855 years old. That means Methuselah was already a mature tree when the first Egyptian pharaohs were consolidating their empire. It was ancient when Abraham walked the streets of Ur. It has survived nearly 5 millennia of drought, frost, wind, and fire through what botanists describe as its extraordinary cellular efficiency. Its wood so dense and resinous that it is almost impervious to the insects and fungi that destroy other trees. But Methuselah, old as it is not the oldest organism on Earth. That distinction belongs to a tree in Utah called Pando. Pando doesn't look like what most people imagine when they hear the word tree. It looks from above like a forest, an enormous grove of quaking aspen trees spread across 106 acres in the Fish Lake National Forest. But those individual trunks, more than 40,000 of them, are not separate trees. They are all connected underground to a single root system, a single organism. Pando weighs approximately 6 million kilograms, 6,000 metric tons, making it the heaviest known organism ever measured on Earth. And its age? Scientists estimate that the root system is somewhere between 80,000 and 1 million years old. 1 million years of continuous life in a single organism. Think about what was happening on Earth when Pando began. Homo sapiens did not exist yet. The species we recognize as fully modern humans wouldn't appear for another 40,000 years at minimum. Pando was already there, already growing, already spreading its root system across the Utah Plateau. These are real, documented, scientifically verified facts, and they already force us to reconsider something fundamental about what we know about trees. If organisms like Pando can exist, single living entities covering more than 100 acres, then what were the limits of biological life in the deeper past? What grew here before the ice ages, before the extinctions, before the events that reshaped the surface of this planet? The fossil record gives us some answers. And those answers are, depending on your perspective, either entirely reassuring or deeply unsettling. The largest trees that ever lived on Earth, according to the fossil record, were the prototaxites. These were not trees in the modern sense. They were enormous fungal organisms that lived approximately 420 to 350 million years ago, before vascular plants had evolved to their modern forms. The largest specimens discovered reached heights of nearly 9 meters, about 30 feet, with trunks up to a meter in diameter. By modern standards, that's not particularly impressive, but the context matters. At the time prototaxites lived, the tallest plant life on Earth was roughly knee-high. These organisms were, relative to their environment, structures of almost incomprehensible scale. Imagine a world of moss and low ferns, and then imagine a single organism rising 30 feet above all of it. That is what prototaxites was. Then came the Carboniferous period, 300 million years ago, and something happened to the plant life of Earth that has not been repeated since. The trees of the Carboniferous were not like anything alive today. They grew in vast swamp forests that covered much of what is now North America and Europe. Species like Lepidodendron, the scale tree, reached heights of nearly 50 meters, with trunks more than a meter in diameter, covered in distinctive diamond-shaped bark patterns that no living tree has replicated. Sigillaria grew to similar heights. Calamites, giant horsetails, formed dense undergrowth 30 meters tall. These forests were so vast, so productive, so overwhelming in their biological output that the organisms living in them could not decompose fast enough. The wood piled up. Layer upon layer of dead Carboniferous trees accumulated in the swamp sediments, compressed over millions of years into the coal seams that powered the Industrial Revolution. Every time a coal-fired power plant generates electricity, it is burning the compressed remains of a 300-million-year-old forest. The world has had forests before that we cannot fully imagine from our current vantage point. Now, here is where the story becomes interesting in a different way. Every major ancient civilization, without exception, has in its mythology a tree that connects earth and heaven. A tree so large that it functions not as a plant, but as a cosmic structure, a pillar between worlds. The Norse called it Yggdrasil, the world tree, an immense ash tree whose roots extended into 3 separate realms: the realm of the gods, the realm of the giants, and the realm of the dead, whose branches reached into the heavens, whose trunk connected everything that existed. The Mesopotamians described the Kiskanu, a sacred tree that grew in a place called Eridu, the first city, the navel of the world. A tree whose roots reached down to the freshwater ocean beneath the earth and whose crown touched the home of the gods. The Mayans spoke of the Cyber, the world tree Wakachan, that connected the underworld, the earth, and the sky. That stood at the center of the universe as an axis around which everything else turned. The Egyptians described the Ish tree, a great sycamore that stood at the boundary between the living world and the afterlife, where the gods wrote the names of pharaohs on its leaves to determine the length of their reign. In Hindu tradition, the Ashvatha, the sacred fig tree, was described as having its roots above and its branches below, connecting the divine realm downward into the human world. These are not the same culture. They have no direct contact with each other. The Norse had no knowledge of the Mayans. The Mesopotamians had no knowledge of the Hindu traditions, and yet they all remembered the same tree. A tree that reached the sky, a tree that connected worlds, a tree so large that civilizations, divine and human, existed within it. The question I keep returning to is the same one historians always deflect. Why a tree? Of all the possible metaphors for cosmic connection, a mountain, a river, a road, a bridge, why did every major civilization on Earth independently arrive at a tree? Let me tell you about the Wollemi pine. In 1994, a park ranger named David Noble was hiking through a remote canyon in the Wollemi National Park in Australia, about 150 kilometers west of Sydney. He stumbled on a grove of trees he didn't recognize. The leaves were unusual. The bark was unusual. The overall form was unusual. He brought samples back to the Royal Botanic Gardens in Sydney, and the botanists who examined them were unable to classify the tree as any known living species. They sent the samples for further analysis, and what came back was extraordinary. The Wollemi pine, which is not actually a pine, but a member of the ancient Araucariaceae family, was known only from the fossil record. Scientists had specimens of it dating back 200 million years. They believed it had gone extinct 2 million years ago, during the Pliocene epoch. It had not gone extinct. It had been hiding. In a remote Australian canyon, a population of fewer than 100 adult trees had survived, completely unknown to science, through 2 million years of climate change, ice ages, and continental shift. The Wollemi pine is now one of the most protected plants on Earth. Its exact location is classified. Visitors are not permitted at the site. Botanists who work with it must follow strict decontamination protocols to prevent pathogens from reaching it. And the question the Wollemi pine raises, quietly, without fanfare, is this. If a tree species could survive for 2 million years in a hidden canyon without any human being knowing it existed, what else might have survived? What else might be hidden in the remote corners of a planet that is still, in many ways, incompletely explored? Now I want to return to Devil's Tower, because I promised to be honest with you about what we know and what we don't. The scientific explanation for Devil's Tower is well established. It is volcanic rock. Its columns are the product of cooling magma, not cellular biology. The claim that a root system was discovered beneath it, a claim that circulated widely on social media, was false. The image used to support it was actually a diagram of sweet corn roots, mislabeled and shared millions of times. I'm telling you this because I think it matters. The mystery of ancient trees doesn't need fabricated evidence. The real story is already extraordinary enough that it doesn't require enhancement. What Devil's Tower actually represents, honestly, accurately, is this. It is a geological formation that formed through processes that are themselves barely understood. Geologists have 3 competing theories about exactly how it formed. None of them has been universally accepted. The National Park Service acknowledges on its own website that its formation has remained a mystery. The Native American peoples of the region, the Lakota, the Cheyenne, the Crow, have their own explanations for Devil's Tower. They call it Bear Lodge. They consider it sacred, and their oral traditions about it are, in some cases, older than the geological theories. The Lakota tell a story in which a group of children, fleeing from a bear, prayed to the earth for protection. The earth responded by raising them upward on a column of rock, out of the bear's reach. The scratches on the tower's sides are the marks of the bear's claws. Now, I am not suggesting that the Lakota story is literally true, but I am suggesting that a people who lived alongside this formation for thousands of years, who observed it in all weather and all seasons, who built their understanding of the world partly around its presence, their relationship to it is not nothing. It is not superstition to be dismissed. It is a long and careful form of attention. And what they noticed, what they encoded in story, was that this place was different, that it rose from the earth in a way that didn't quite fit the pattern of the surrounding landscape, that it demanded an explanation that went beyond the ordinary. Here is the part of this story that I find most difficult to leave alone. In 2019, researchers studying ancient forests in the Canadian Arctic discovered something unexpected. Beneath the permafrost of Ellesmere Island, one of the most remote places on Earth, well above the Arctic Circle, they found the preserved remains of a forest from the Devonian period, 380 million years old. The trees were not large by modern standards, but what the researchers found in the soil around them changed the way scientists understood the relationship between trees and the planet. These ancient trees had root systems that extended far deeper into the bedrock than anyone had expected, and as those roots grew, they fractured the rock, released minerals, transformed the chemistry of the soil, and eventually the chemistry of the ocean. The researchers concluded that the spread of these ancient forest root systems was one of the primary drivers of the late Devonian extinction, an event that eliminated approximately 75% of all species on Earth. Trees killed most of life on Earth, not through malice, through transformation, by remaking the chemistry of the planet so thoroughly that most existing species could not adapt quickly enough to survive. The world was changed by its forests, and then the forests were changed by the world, and then the world changed again. This cycle of forests shaping planets and planets shaping forests is still happening. We are living in one iteration of it. The question the fossil record keeps raising quietly in the rock strata and the coal seams and the petrified remnants of things that used to be alive is whether our iteration is the most recent one or simply the most recent one we know about. I want to end with a tree that's still alive. In central California, in the Sierra Nevada mountains, there is a grove of giant sequoias. The largest of them, a tree called General Sherman, is the largest living organism on Earth by volume. It stands 274 feet tall. Its base circumference is 102 feet. It weighs approximately 1.4 million kilograms. General Sherman is estimated to be between 2,300 and 2,700 years old. It was growing when Alexander the Great was conquering the known world. It was already ancient when Julius Caesar was born. And it is still growing. Every year, General Sherman adds enough wood to make a standard-sized timber tree. The largest tree on Earth is still getting larger. When you stand at the base of General Sherman, and I encourage you to do this if you ever have the opportunity, the scale of the thing is genuinely difficult to process. Your brain was not built to comprehend an organism of that size. You have to override something, some assumption about the relationship between living things and the space they occupy, to truly take in what you're looking at. And then you remember that General Sherman, enormous as it is a fraction of the size of Pando. That Pando, vast as it is, existed long before Homo sapiens did, that the trees of the Carboniferous forests dwarfed anything alive today, that the planet has, in the deep past, supported forms of biological life so different from what surrounds us that they might as well belong to a different world. Because they do. They belong to a different world, one that ended, one that left its traces in the coal seams and the canyon walls and the stories that every civilization on Earth tells about trees that once reached the sky. Whether those stories are memory or metaphor, I cannot tell you with certainty. But I know this. Every major culture remembered a world tree. Every major culture described a time when the boundary between Earth and heaven was closer than it is now, when something enormous connected the ground to the sky. And then it was gone. The question of what it was and what ended it is still, in every meaningful sense, open. My name is Paul. This is Mr. Origins. Subscribe, because the next piece of this story is closer than you think.